thanks for joining me. I'm actually on my way to the store right now, the dollar store to be exact, a special type of dollar store, one without sales tax. So what does that make the price of everything? Yep, that's right, just $1. So if I walk to this dollar store and I see that I only want one item, Mr. Blue, how much does Mr. Blue cost me? That's right, I'm only going to spend $1 on Mr. Blue. So, let's take a record of this just because we're mathematicians, you know. One item is going to have us equal $1, pay $1. Okay, but say I also want this candle and this box of Kleenex so that I can blow my nose since the pollen's so bad. Then I have 3 items, 1, 2, 3. How much money will I spend then? You're right. 3 items is $3 because each thing only costs $1. So what if I use my birthday money, a $20 bill, and I want to spend all of it at the dollar store because, I mean, what else am I going to do with it? How many items can I get? You're right. I can get 20 items. I can have this guy and this and this and oh my gosh, 20 items is a lot. That's so exciting. So 20 items for $20 that I have. But what if I go to the store and I find that I don't like anything? I'm sure you've done that before. You walk around the store and you're like, oh, this store doesn't have anything I need or want. And I walk out without buying anything. So I get 0 items. How much money do I spend? That's right, I don't have to spend any money. That is exciting. At least I didn't lose any of my money. So, what would this look like on a coordinate graph? Well, we've got $1 for 1 item. We've got $3 for 3 items. We got $20 for 20 items. We got $0 for 0 items. So that's awesome. That's a line, it looks like. Pretty straight line. So we can probably predict how much it's going to cost us to do, you know, say 10 items, $10. Oops, actually that's not what I want to put there. Because what I want to know is for any old X, for X items, how many dollars is it going to cost? Well, first off, let's talk about our axes. What are we going to put on our axes? Where are we going to put items and cost? If you don't remember, the y-axis is the dependent axis, and the x-axis is the independent axis. So basically that means that the x-axis is going to act on its own. Whatever it does, the y has to follow. So, which of ours, costs or items, is the one that has to follow? You see, we could go in with $20, and if he's the one we have to follow, then that means we have to spend all $20 every time and get all 20 items. But is that true? No, of course not. There are plenty of times where you've gone in the store and not spent all your $20. So the other thing that we could do or consider is if we get our 3 items and we go to the cash register, do we have to spend $3? Yes, we do. We are, by law, required to spend $3 if we are buying 3 items. So the dollars, the cost, is dependent on the items. So that means for us that our items go on the independent axis, the x-axis, and our cost goes on the dependent axis, the y-axis. So let's label them here, x and y. So what does this mean for us? If we have X items, if we buy X items, how much money do we spend? Well, just like all the others, you got it right. We spend X dollars. So Y equals X. Okay, but we've all been to McDonald's and we've seen that the dollar menu is not the same, that everything has gone up to about $1.69 or so. So this inflation thing is going to ruin us. So what if our store actually charges us $2 per item. So if I go get Mr. Blue, how much am I going to have to pay for him now? You got it, $2. So what about if I buy 3 items? Yeah, multiply by 2, get $6. How about 20 items? Ah, $40. I don't have $40, I only got 20 for my birthday. What about 0? What if we go in this new store and we don't buy any items? You're right, we still don't spend any money. That's awesome. So how do we generalize this? If we're just going to go in the store and buy any old X amount of items, how much money are we going to know to spend? 2 times X. Very good. 2X. So now we have our Y, the cost, equal to 2X. This is going to give us a different looking graph. Let's see. We still start at 0. But now when we go over 1, we go up 2. And then when we go over 3, we go up to 6. So I guess in between we went up another 2. And we just keep going up over 1 and up 2. So how about this sale? Okay. I have something for you guys. There's a sale going on Saturday. They have $5 tickets that we have to buy, and then we can go in the sale and everything's $3. It's a great sale. It's going to be so exciting. You want to go? Yeah, me too. So here's the thing. I want to figure out how much it would cost us to buy just one item there to see how it compares to the dollar store. So if I buy this book, this is really exciting, this book. What is my expenditure going to be? So the book's going to cost us $3. So that's $3. But then we've got to pay this ticket price. So it's actually going to cost us $8 in all. So if we bought 3 items, let's just keep going with all these books. There's lots of great books here. 3 items, it's going to cost us $9, but we still have to pay the $5. 14. And then 20 items is going to cost us $60. We still have the $5 ticket fee. Oh my gosh, it's going to be $65. Will you lend me that? But what about 0 items? Well, if we go to the sale and we don't buy anything because we just don't see anything good enough for us. No, it's not 0 anymore because we still had to buy that ticket, that $5 ticket, to get into the sale in the first place. So it's kind of cool that we got to look around, but we still had to spend money. So what does that leave us for our X? What does it mean for our general number? You're right. We got $3 times X, just like we've normally been doing. But then we have to always remember to add on that extra $5 for our ticket price. So now what we have is Y equal to 3X plus 5. And let's see what that looks like on our graph. At 0, we actually start at 5. And then we go up 3 from there. Go over 1, up 3, over 1, up 3, over 1, up 3. So let's try this on for size. What if we started with the equation and we had Y equals 4X plus 8? Well, yeah, we got our 8 is our ticket price, so that's how much it's going to cost for us to get into the sale. And our 4 is going to be how much money is per item. So what does that leave us for our costs in our table? We have 1 item is going to be 4 plus 8, 12. 3 items is going to be 4 times 3, 12, plus 8, 20. 20 items is going to be 4 times 20, 80, plus that 8, $88. Oh my gosh. 0 is going to be 4 times 0 plus 8. And then our x is going to be just like our equation, 4x plus 8. Interesting. So how do we graph that? Well, we start up at the 8, like we did on that 3x plus 5. And then we go up by 4s. Over 1, up 4. Over 1, up 4. Ooh, it goes off the graph. Interesting that we can go from the equation to the graph and to the table. So let's try one more, and then I'm going to go over some vocabulary with you. What if we had y equals 0.50x plus 2? Think about that one for a little bit. Yeah, you got it. Everything is 50 cents, and it's $2 to get into the sale. That's a really great sale. We should probably go to that one. So if we bought our one item, we're going to have, we're going to run out of space. Let's just think about this. For our one item, we're going to have 50 cents plus 2, so $2.50. For our 0 item, we're going to have 2, just like you expected. For our 3 item, we're going to have $3.50. So we can continue. For our 20 items, we do 0.5 times that. We're going to have $12. And then the same thing at the bottom. So the question is, what do we do in our graph? So first off, we have to start at our 2 ticket price. And then we go up by 50 cents. So if we buy one item, we just go up half. If we buy another item, we go up half. What if we decided to buy, we're going to use $1. How many items can we get? Two items for $1. So that means that we could go over 2 items and up $1, and then over another 2 items and up $1, and keep going like that. And that's how we can know how to graph it. Well, that's very exciting. So let me tell you about the vocabulary that we've seen in this lesson. Slope is this number right here, the 4 and the 0.5 and the 3 and the 2 and the 1 that we've seen, because it is our dollars per item. It's our change in Y over change in X. So basically what that means is when we look between the two X or Y's, we go up to here and we go up to here, and then we do 2 over 2 and we get 1. And so we know that each item is $1 because it changes by 1 every time. And when we look at our graph, it goes up by 1 every time. Then there's this word, so I'll put that there, slope. There's this word y-intercept. The y-intercept is named as it is because it intercepts the y-axis. So it's this point where the line goes through the y-axis. It's where x equals 0, and in our schema, it's the ticket price. So anytime you see a ticket price, $5 here, there's $8 over there, and $2 in the next example, that's when you know you have a y-intercept. And that is the number that you can add on to the end. So that leads us to what this form of equation is called, which is slope-intercept form. Slope-intercept form is y equals mx plus b. M equals slope and b equals y-intercept. You can remember this because b stands for beginning. It's where the ticket price is, where you have to start with when you go in, regardless of how many items you buy. And m stands for movement. So that's how you can think about per item, I have this amount of money to pay. So this is a slope-intercept form, and anytime you see the slope-intercept form, you know you have two pieces of valuable information. the starting point on the y-intercept, on the y-axis, and the slope of how much you go up and over by. So that's all we have today, but I hope you learn more, and I hope you stay tuned for more information about linear equations.